Hello everyone, myself Mr. Kiran Achinswalkar, lecturer in Mechanical Engineering Department from Praveen Patil College of Diploma Engineering and Technology. We are starting chapter number 3, casting processes and plastic molding. Today we are starting part number 3. Now we see learning outcome. After watching this video, you get the following learning outcome. First, you should able to know molding processes. Second, you able to know classification of sand. Then third, different properties of molding sand. Point number 4, classification of molding processes. Point number 5, different types of core. And point number 6, gating system. Now we see molding. Molding is a process in which a cavity of desired casting is formed in a mold. Second point, after withdrawing the pattern from the compacted sand, the cavity produced is called as a mold. Point number 3, when molten metal is poured in this cavity, the desired casting is obtained. Now we see classification of molding sand. Point number 1, according to nature of origin. First type of sand is a natural sand. First point, it is also known as a green sand. Point number 2, it is obtained from bed of river. Point number 3, it is in a natural moist state. Point number 4, it is mixture if silica sand with 18 to 30% of clay and 6 to 8% of water, which provides a bond. Point number 5, it can be directly used for preparing mold of smaller and medium casting. Point number 6, it can maintain moisture content for longer time. Point number 7, it permits easy patching and finishing of mold. Second is a B, synthetic molding sand. Point number 1, it is made by mixing clay-free sand with a suitable binder such as bentonite, water and other materials. Point number 2, it can also be prepared by bonding silica sand with 4 to 5% land cement. Point number 3, its properties can be controlled. Second classification according to use. First point A, green sand. It is silica sand moist in natural condition. Second, 18 to 30% clay and 6 to 8% water provides the bond. Point number 3, green sand mold are used without drying by saving the cost and time required for drying. Point number 4, these molds are suitable for small and medium casting. Point number B, dry sand. Point number 1, green sand which is dried or baked in oven after the mold is made is called dry sand. Second point, sand molds have greater strength, rigidity and thermal stability. Point number 3, it is used for larger casting. Next is a point number C, facing sand. In this point number 1, it forms the face of the mold which is next to surface of pattern. Point number 2, it is specially made from silica sand and clay without addition of used sand as it comes in contact with the molten metal. Point number 3, it must possess high strength and withstand high temperature. Point number D, baking sand or flour sand. It is used for baking up the facing sand and fill up the wool flask. It is old repeatedly used molding sand. Next point number E, black sand. The floor sand is also called as a black sand because of its black color due to addition of coal dust and its burning on coming in contact with the molten metal. Next types of sand, this is loam sand. It is high in lay up to 50%. It become very hard on dry. Second point, it is used for loam molding for large casting. Next sand, point number G, core sand. In this point number 1, it is used in machine molding. Second point, it should possess high strength, permeability and refractoriness. Third point, it is used to prepare cores. Point number H, parting sand. In this point number 1, it is dry silica sand or sea sand. Point number 2, it is sprinkle and pattern surface to prevent the mold sand from sticking to it. Point number 3, it is also used between the parting surface of drag and core to prevent them to sticking together when they are separated for withdrawing the pattern. Now we study properties of molding sand. First property is porosity or permeability. When molten metal is poured into the sand, steam and other gases are evolved. This sand, therefore, should have sufficient permeability to allow these gases, steam, to escape, otherwise pores or gas hole are caused in the casting. Second property is refractoriness. The sand should be capable of withstanding high temperature without melting or softening. By this, better casting surface is obtained and cleaning of casting become easy. Now we see the third property, cohesiveness. It is the property by which sand particles stick together. When water is mixed in the sand, it should provide sufficient bond or strength to hold together to retain shape of the mold even after the mold is poured. Next property is plasticity. It is a property of the sand to acquire a shape under pressure and to retain that shape when pressure is removed. This property of sand gives good impression of the pattern in the mold. Fifth property is adhesiveness. It is a property of sand to stick to another body like side of the molding box. Due to this property, the sand mass can be successfully held in molding box and does not fall out of box when it is lifted. Sixth property is a thermal stability. The sand should have dimensional thermal stability at high temperature. Because of this property, the mold surface does not break, buckle or flake off. Seventh property is flowability. Due to this property, sand flow easily in the mold and take up the sharp impression of the pattern. In other words, under pressure sand pack off well. Eighth property is collapsibility. For easy removal of casting, the sand mold should break or collapse easily after solidification of molten metal. Ninth is reusability. The sand should be reusable and should give good casting surface. These are some properties of molding sand. Next, we study classification of molding processes. First type is bench molding. In this first point, the method is used for small work. Second point, small molds which can be easily lifted by single worker are normally prepared on a molding bench. Third point, the molding bench is conveniently designed for storing sand and keeping molding tools. Fourth point, molds prepared by bench molding is shifted to some other place for metal pouring. Next type of molding processes is floor molding. First point, the method is used for medium and large size casting. Second point, floor molding is done on floor itself because large and medium molds are difficult to ship or handle. Point number 3, as the mold cannot be shifted, the metal is directly poured into the mold cavity of the floor itself. Point number 4, the molds are prepared on the foundry floor similar to green sand molding. Now we study core. First point, core can be defined as a body of sand generally prepared separately in a core box which is used to form a cavity of desired shape and size in a casting. Second point, during molding operation, cores are separately placed in a molding box after withdrawing the pattern. Third point, this projection is formed by pattern itself or it may be made elsewhere and introduced into the mold after the pattern is withdrawn. Now we see core print. First point, the core print is an added projection on the pattern and it forms a seam in the mold on which the sand core rests during pouring of the mold. Second point, the core print must be of adequate size and shape so that it can support the weight of the core during the casting operation. Third point, depending upon the requirement, a core can be placed horizontal, vertical and it can be hang inside the mold cavity. Now we study different types of core. Different types of cores with various shapes and sizes are used in a foundries. The types of cores according to shape and position are given as. In this diagram, we can see that first is a core with end support, second is a vertical core, third is a balanced core, and fourth is a hanging core. Now we study each core in a details. First is a horizontal core or core with end support. It is most commonly used type of core. The core is laid horizontally at the parting line of the mold. The end of core are supported in the seats provided by core prints in the pattern. Second core is a vertical core. It is placed in a vertical position in the mold with major portion in the drag. Usually top and bottom part of the core are tapered. Next core is a balanced core. When blind core along horizontal axis is required, this type of core is used. It is supported at only one end with sufficient length of core embedded. Fourth is a hanging or cover core. If the core hangs from the core without any support at the bottom of drag, it is called as a hanging core. These are some types of cores. Now we see gating system. The channel or passage through which the molten metal flow to the mold cavity is called a gate. Well-designed gating system is required for production of good, flawless and high-quality casting. Now we see elements of gating system. At top of the diagram, there is the elements of gating system. We start from top side. There is a pouring basic, then there is a sprue, then there is a sprue well. On right hand side, there is a runner, then gates to the casting and runner extension and runner well. At bottom of the gating system with molding box, we can see there is a pouring basin, sprue, parting lines, runner, riser, mold cavity, core prints. Now we study these elements of gating system in details. First element is pouring basin. The molten metal is not directly poured into the mold cavity because it may be cause mold erosion. Second point, the molten metal is poured into a pouring basin. A pouring basin is enlarged portion at the top of sprue. Pouring basin acts as a reservoir for molten metal, from which it moves smoothly into the sprue. Second part is sprue. Sprue is the channel through which the molten metal is brought into the parting plane, where it is enter the runners and gates to ultimately reach the mold cavity. Third part is a runner. In large casting, molten metal is usually carried from the sprue base to server gates around the cavity through the passageway called as a runner. The runner may be located either in a cope or drag part of the mold. It is advantageous to keep the runner in the cope part as it also works as a riser. In such cases, riser may not be used. Last part is a riser. A riser has added reservoir designed to feed liquid metal to the solidified casting for compensating for solidification shrinkage. Then next part is the gate. These are the opening through which the molten metal enters the mold cavity. The shape and cross section of the gate should be such that it can readily be broken off after casting solidification, and also such that it should allow molten metal to enter into mold cavity smoothly. I hope you understand this presentation. Thank you.